Alright, this video is the first part for our classification unit, and this is part 1, and we'll be talking about scientific naming, binomial nomenclature, and dichotomous keys. So why do we need to classify? Well, there's 3 reasons. One of them is to be able to study the diversity of life. There are a lot of organisms, and we need to have a way to divide them up and to kind of put them in categories. The other reason is to name the organisms, and then when you group the organisms and name them, it needs to be in a logical manner. So in part of classification, you have an area of science called taxonomy, and these are scientists who actually name organisms. They classify them and they give them a name that anyone can understand in any language. So science requires larger and smaller categories. So for instance, this is a bird, but what type of bird is it, right? And you would need to be able to classify it by probably looking at the characteristics of it. So another reason is that scientific names help to avoid confusion. So in some parts of the country, this might be a puma, it might be a mountain lion, it could even be a cougar. But in reality, they're all the same organism. So we give it what's called a scientific name. The scientific name for this one is Felis concolor. If you remember, Felis means feline or a cat, and then concolor is the specific name for it. So scientists use scientific names. Number 1 is to avoid confusion. And they will use Latin and Greek words. They still use the Latin and Greek today because Latin and Greek are not changing. They're considered dead languages, and their words aren't changing anymore. So in the 18th century, they used to try to name organisms according to the physical characteristics. But what ended up happening was that there are too many words. So it might be black, rough fur, 5 feet tall. You can imagine how many different characteristics you would add in order to specifically identify an organism. And sometimes scientists would use different characteristics for the same organism. So in the 18th century, a guy named Carolus Linnaeus came up with a system, and his system is called binomial nomenclature. And with the binomial nomenclature, you have what's called a 2-part scientific name. The first part of the name is called the genus. Genera would be plural, and what a genus is a group of closely related species. The second part of the name is called the specific epithet, or the species part of it, and that would be unique for every organism within a species, or within a genus, I'm sorry. So here are the rules for writing a scientific name. First of all, the first letter of the genus name is always capitalized. The rest is lowercase, and then the specific epithet is lowercase. If a scientific name is written in a book, it needs to be italicized. So if you're typing it, you need to italicize it. If you're writing it by hand, you should underline it. Now, if you're writing it, say, in a paragraph, the first time you write it, you need to write the genus and species all the way. So in other words, you write the whole genus, and then you write the whole specific epithet. Now the second time you write it, you can abbreviate it with the first letter. So for instance, if I had Homo sapiens, okay, let me go ahead and get this out. If I had Homo sapiens, this is how I would write it. Okay, and make sure I underline it. Now the second time I wrote it, I could just put H period sapiens and then underline it. Okay. So what I'd like you to do is go ahead and write these names correctly. Okay. So what you need to do is what? Make this a capital letter, right? So So capitalize first letter, right? And underline them. So what do the names tell you? Okay, so with these scientific names, we have a grizzly bear and we have a polar bear. Now they're both bears, so what do you think the genus is for bears? That's right, it's probably right here, this part here that says Ursus. And this right here tells you two different types. Now you would think Arctos would be grizzly or Arctic would be the polar bear, but I also found where some places where it says Ursus horribilis, which would be horrible bear. And then a polar bear is Ursus maritimus. Maritimus, think of maritime, near the water, which polar bears are. Okay. So you will do, after you watch the video, you'll do these two sheets right here, which the teacher will pass out to you, or I'll pass out to you rather. Okay. Then I want you to be able to know what a dichotomous key is. A dichotomous key is used to identify organisms, and it's used, the way you use it is you use paired statements to describe the characteristics of an organism. For example, the presence or absence of certain visible characteristics or structures, right? So for example, I might say it's 5 feet tall, it's over 5 feet tall, under 5 feet tall. I might say something is blue or not blue. Normally you use opposites as far as in the paired statements. Try to do your best and not use relative characteristics. For instance, don't say something is soft, because something might be softer. Okay? Don't say something is tall, because tall is relative. You might be tall next to your friend, but next to your dad, you're short. So try not to use relative characteristics. So here's an example. Here's an example of a dichotomous key. Okay, try to make it a little bigger here. So if you look right here, going to be right here. We're looking at this insect here. So does the insect have wings? Well, insect has no wings. So we say that it has wings, right? And then what? We go to number 2. So because your insect has wings, you go to choice number 2. If your insect did not have wings, where would we go? That's right, to choice number 9. So since it does have wings, we go to 2. Our insect actually has 4 wings. I don't know if you can see them, but you see these 2 here, and there's another little one. Hold on. There's another little one right there. So it has 4 wings. So rather than going to question 3, where are we going to go? That's right, to question 12. Now, question 12 might give the following choices. Wings are equal, wings are unequal size. Which set of choices would you proceed to next? Okay, so we would say unequal, right? So that would take us to 18. Now, eventually, you're going to reach a choice that doesn't direct you to another set of choices. Instead, it will say the identity of the organism. So if we go to 18, it says long fin projection in the rear, which it does have, right? And then it would be a mayfly, no projection in the rear. It would go to 21. But since it does have that, our organism is a mayfly. Okay, so that stops this part of the video.